Okay, so welcome back to my YouTube channel. Okay, so here we have our question on maclaurine series. We want to approximate the value of pi using maclaurine series. Okay, so we are given the expansion of x side. We are given the expansion of x side up to what? This fourth degree. Okay, so we want to evaluate this about x is equal to 0.5. Okay, so we are told that okay, pi can be found by taking the x sign of 0.5 and then multiply it by what? 6. And we know that the x sign of 0.5 is simply pi over 6. Okay, so pi over 6 times 6, you notice that we're going to have a pi there. All right, so this expansion given here, you have to use this expansion to find it, the value of pi. Okay, so let's start. So we're evaluating this about x equals 0.5. Okay, so we're evaluating this about x is equal to 0.5. Okay, so we're given arc sine. Arc sine is same as sine inverse. Okay, so arc sine of x, its expansion is given. Okay, plus so on and so forth, right? Okay, so of course, there is a condition. I just left out that condition, saying we have to evaluate this to 3 significant figures. Actually, it's there already. I didn't just see it. Okay, we're evaluating this to 3 significant figures. And what does this mean here? This is stopping criteria given to us. So it tells us when we should stop doing the iteration. Okay, because every iteration will be improving the value of pi. So now we need to be given the stopping criteria. When are we supposed to stop? So this one is simply the upper bound of error. So it's actually the relative error. We need to check every time we do the iteration. And that relative error is given as follows. So the present approximation minus the previous approximation divided by the present approximation, this is the relative error, should be less or equal to 5 times 10 to the power negative t. That's the condition. Okay, where t is actually the value mentioned there, 3 in this case. So at every point, we need to make sure that we are not exceeding that. So when you find the relative error, you have to check this condition. So in this case, our t is equal to 3. Okay. So let's start doing the approximation. So what's the present error here? Our present error is actually already given 0.5. Okay. So I'll be doing this in segments. I'll say that. So first to get the first part, we substitute x equals 0.5. That will be our initial value of x. So I need to get x naught. So x naught will be equal to 0.5. Okay, by just substituting the value of x in this. And then our x1 will contain 0.5, will contain this, right? Time will say plus the next term, which is x plus 1 over 6, x power 3. And then if you substitute x is equal to 0.5, what do you get? So x is equal to 0.5, 1 over 6 plus 0.5, times 0.5 to the power of 3, right? So this is about it. So 0.5 plus 1 over 6 times 0.5 to the power 3. So this is about 0.52083. Okay, and then our x2 will be, if we add the first 3 terms, that will give us our x2. So our x2 will be equal to the previous one. So just because this one here, x plus 1 over x power 6, that already giving us 0.52. So the 0.52 plus 0.52083 plus the next one, the next term is 3 over 4 t 0.5 to the power 5. Okay, so we add that. So we are getting about 0.523177083, just like that. Okay, so our x3 can go on and so forth. Okay, so x3 will be this value plus the next term 0.5, 23177,083 plus the next term, and the next term is 5 over 112, and then 0.5 to the power 7. Okay. And this gives about it plus 5 over 112, 0.5 to the power 7. So this is equal to 0.5235. Okay, 258557. Okay, something like that. So now we need to make sure that we check this condition, right? Now remember that this is just arc sine, right? Arc sine is equal to that. But in our approximation for pi here, arc sine is has to be multiplied by 0.5, sine has to be multiplied by 6. So we need to make sure that we're also multiplying these values by 6. Okay, so we have to multiply all these values, we're getting by 6. Okay, again by 6. Okay, so if we multiply those values by 6, so I'll say our P naught will be equal to what? So instead of writing x naught, now write P naught, because those are approximation I want. So the first one will be P naught equal to 3, and then P1, okay, P1 corresponds to x1, that will be 0.52, 0.83, repeated times 6. Okay, so this is about 3.12498. This is our next approximation. And then P2, which is our next approximation and improvement to the previous one. So again, 6 multiplied by this value there. So 6 by 0.523, 177083. We have about 3.139062498. And then P3 will be equal to, again, we also multiply this by 6, our x3. So 0.52, 35258557 times 6, we get about 3.14. So you notice that we are improving the value of pi, right? For each iteration. Okay, 145513. So this is the value of pi about 3, but we have 3.12, or about 3.139, and this 3.14. Okay, something close to pi. Now we don't have to continue doing all those approximations because we're not going forever. We can also find P4, P5, and all that. But we are given the condition here. So it's okay, we need to stop when this condition is met here. So we have to check those conditions at every point. So let's go ahead and check the condition. So we start with the first the condition. So remember that is a present approximation minus the previous approximation, by the present approximation. So our present approximation here is, so we start with, remember, we just pick two sets at once. I mean, two, a pair. So pick this one here. The next one, we're going to check this one and this one. The next one, we're going to check this one and that one. Okay, so checking that condition. So we start with P1 and P naught. So P1 and P naught, P1 becomes our present approximation. P naught becomes our previous approximation. So 3.12498 minus 3 divided by 3.12498. Okay, so the relative error must be less or equal to 5 times 10 to the power negative 3. So does that meet our condition? Okay, let's say 3.12498 minus 3 divided by 3.12498. Okay, so this is about 0.04, and this is not true, right? 0.04 is actually greater than 5 times 10 to the power negative 3. Okay, so we have to check the next one. So the next one here with P1 and P2. So P2 becomes our present approximation. So we have to check that condition as well. So 3.139062498 minus 3.12498 divided by 3.139062498. Okay. So let's check if this indeed is less than 5 times 10 to the power negative 10. So negative 3. Okay, so So 3.139 062498 minus 3.12498 divided by 3.1390 62498. Okay, so this is about 4.486 times 10 to the power negative 3. And indeed, this is less than 5 times 10 power negative 3, right? Okay, so this condition is met, so we can stop doing iteration. So from this, we can make the conclusion that the approximation for pi is simply approximately equal to the present approximation just from finding, which is about 3.139062498. So if we are to go, if we are to, do more iterations, you notice that we're going to get closer to the true value of pi. Okay, you notice that P3 actually was even better than P2. So imagine if you had found P4, P5, P6, so on and so forth. Okay, so thank you so much for watching. I'll see you in the next video.